Today we're here to talk about ions. The key ideas I want to talk about are traditional methods of talking about ions involve using these kind of objects. This one here could, for example, represent a nitrogen, a chlorine, an oxygen, and maybe a hydrogen. But I want to do a bit more than that. I want to show you one or two applications. So we're also going to learn how to test for ions as well. Here are some examples of some types of reactions. These are all common to GCSE students. The precipitation reaction, this one here, is the one I'd like to focus on today. Before I do that, I just want to introduce or remind you to a few of the other reactions. The first one is decomposition reaction. This one can be shown quite nicely. You can see there's two ions, a positive ion and a negative ion, which are being split up, hence decomposition. This is called a double displacement because the metal ions involved are swapping as well as the non-metal ions. It would be nice to illustrate this in other ways, and I'd like to do a demonstration over here of what's going on. First demonstration I'd like to show you involves lead nitrate and potassium iodide. We've got positive ions and negative ions mixing together. At the moment, two liquids, clear liquids, if we put them together, wow, you can see we've had a chemical reaction occur and we've formed a bright yellow precipitate, the kind of precipitate that you may link with the yellow on roads that's used to paint double yellow lines. We've got another example here, and you can see the same kind of idea. We're thinking about precipitation reactions, which means you're putting two liquids together to form a solid. And you can see this time it's forming a white solid. Why is this important? Because we can use this to test for certain ions, especially non-metal ions. In these test tubes I have three different ions, and if I add a chemical called silver nitrate to these, they will behave very similarly. They are proving that certain halides are present. Same idea again, it's forming a precipitate. There's one, here's another one. The halogens, by the way, are group 7. Chlorine, bromine, iodine are the first three. And you can see that they're all doing something rather similar, but when I hold them up, you may pick out that there's a slight difference in variation in the colour. And it's that colour change which is really useful for us, that allows us to chemically test for the different ions. That's the purpose of what we've done there. We can also apply this for other examples, such as testing for sulfates. You test for sulfate by adding a chemical called barium chloride. Now barium chloride, I have some just here, can be carefully added, and again we're looking for a similar result. You can see a white precipitate being formed. All of these are positive tests for ions, and this is really, really useful for us. Okay, as I finish, I just want to give you, let's try that again. As I finish, I want to give you a few examples of ions in action. You can see a couple of examples here. We've got water purification, and we've also got the idea of hard water, soft water. And I think both of these applications show ions in action.